Here we go. Domain. The domain is referring to the possible x values in a problem. So we're going to draw a picture of it so you have an idea first. So that's the square root. Square root of what? 16 minus 4x squared. So what does it look like? Top half of a circle. And it looks like it's gone, you know, part of this is we don't have, you know, a bunch of high-tech people writing programming, and these aren't high-definition screens that we're dealing with. That should come down to the x-axis. So don't think that it stops where it's stopping. It just, you know what I mean? Okay, so it should come down to the x-axis. So that's what it looks like. What x values does it cover? Just looking at the graph. It goes from -2 to 2, right? So by taking your calculator and sketching it, you kind of have an idea of what it's covering to begin with. Now, when you deal with the square root, what are you guys concerned about?
Plus and minus.
You are concerned about plus or minus, but if the stuff underneath the radical is negative, can you work with that?
No.
No. If the stuff underneath the radical is 0, can you do that? Can you take the square root of 0?
No.
Try it.
Yeah.
Can you take the square root of 1?
Yes.
Can you take the square root of -4?
No.
Yeah.
Can you take the square root of 4?
Can't take a square root of negative.
Okay? So mathematically, using inequality symbols, how could I say that I want to take the square root and make sure that everything in this problem is 0 or more? How can I write that? How do you write, I want this stuff to always be 0 or more?
Greater 0.
Just 0?
Yeah.
So that will make sure that it's 0 or more all the time?
You got a square root symbol.
No.
You can do greater than or equal.
That makes sure that it's always 0. So the only solution you're looking for is 0? No. Let's add the greater than to allow the numbers to be more. So get rid of that, and let's make it that. So if we solve this, it will ensure that anytime somebody plugs one of our answers in under the radical, that they will end up with at least 0 or something more than 0. Does that make sense? So understand right now, anytime somebody asks you about a domain, you know, look here. With square roots, we don't put the number 2 there, right? No. So if that number is a 2, which we typically will not write, or a 4, or a 6, or an 8, or a 10, we're dealing with what's called an even root. You start the problem like this. You set it greater than or equal to 0. If that number is odd, like a cube root or a fifth root, it doesn't matter. It's all reals. Even roots, you have to be careful. Odd roots can be anything. So We know how to solve this. So let's try to factor it. 16 and 4x squared, you could factor it like a difference of squares. Some of you might even say, oh, 16 and 4 have a 4 in it, so we could pull a 4 out front. Now I know the 4 minus x squared is a little bit backwards. You're used to seeing it x squared minus 4. But it's still a difference of squares. So I still have the 4 out front. So now I have 2 minus x and 2 plus x. So what are your critical values? 2 and negative 2, right? Setting 4 equal to 0, does that even make sense? No. So that, whether you work with 16 minus 4x squared or somebody else works with 4 minus x squared, you're both going to be dealing with the same critical value. So on a number line, put your negative 2 there and your 2 there. What do you put above them?
Close.
Closed dots. Does anybody in here know what happens when you have a negative in front of your x squared term? What does that do to your parabola? Flips it down, right? So I know my parabola is doing this. So either you know that or you don't. If you know it, tell me where the parabola is above the line. Outside of the critical values or inside of the critical values?
Inside.
In between the blue dots, my parabola goes above the line. Right? So that's your answer. Right there. Negative 2 to 2. Let's say you don't know what the parabola is doing. You totally forget. It's on the non-calculator. You totally forget. What could you do? Pick a number between negative infinity and negative 2.
0.
Negative 10. 0 would be over here.
Okay.
Negative 10. What happens when you put a negative 10 here? That's positive. What happens when you put a negative 10 here? That's negative. What happens when you take a positive times a negative? Negative. What are we looking for? Things that are greater than 0 or have positive sign. Now, between negative 2 and 2, what are you going to use? 0. Plug in 0. I get 2. Plug in 0. I get 2. So it's... Now, technically speaking, because of the 4, there is an extra positive hanging out front, but what happens when we multiply all positives together? Positive. That's why that's our solution. Out here, pick 10. Plug it in. Negative. Plug it in. Positive, so it goes positive. Negative, positive. That's why your answer is negative 2 to 2. Okay?